Okay, once again, this is just a review for the actual test itself. You should be familiar with this material, so I'm going to kind of walk you through it and just give you some general pointers as we go along. Identify each of the following as a simple statement: compound statement, opinion, or command. A simple statement expresses a single idea, okay, that is either true or false. 2 is a counting number. That's a single idea, and it's either true or false. So this is a simple statement. So the first one's a simple statement. I need to get my pen working here. Bill is here, or he did not come to school. This is actually a compound statement because here's a simple statement. Bill is here. He's either here or not. He did not come to school. It's either true or false. It's joined by the connective or. So this is actually a compound statement. Okay? Please take the dog for a walk. That's a command. That you're telling somebody to do something, right? So that is not a simple statement. That is a command. It is not the case that Scott has a nice car. It is not the case that Scott has a nice car. This is an opinion because the word nice is subjective. Some people might think it's a nice car. Someone else might think it's not. So this is an opinion. But we're mostly concerned with what we know in terms of what simple statements are and compound statements. The next thing, match each of the following statements on the left with its negation on the right. The negation is the statement whose truth values are opposite of the statement itself. Usually you have trouble when you're working with one of the quantifiers like some, none, all, etc. Identify the word some with at least one. Think of one because if you're talking some, you need only one. So, some gumbo is not good. So, in the world of gumbo, some gumbo is not good. So, here's the world of gumbo that is good. We know that there's at least one gumbo out here that is not good. Now, there could be a gumbo on the inside that is good. To negate that, we have to move that one gumbo inside. Some gumbo is not good. All gumbo is good. So it'd be C. I like to draw a little picture. So this is the good gumbo. And I have at least one gumbo that's not good because of the word some. If I get rid of it and I bring it inside, all the gumbo is good, right? Moving on. Second one, all gumbo is good. Well, if all gumbo is good, here's the world of good gumbo. And we have all the gumbo is good. It only takes me to move one gumbo to the outside to say that, to negate that statement, right? If I move one outside, then the negation of that is some gumbo is not good. B, some gumbo is not good. No gumbo is good. Well, if no gumbo is good, there's nothing inside my circle here, right? There's no gumbo is good. There's gumbo out here that is not good. Once again, it only takes me to move one of them to the inside, and that is one. Some gumbo is good, right? Whenever you have one, get rid of that little spot right there. Don't confuse that one there, okay? But no gumbo is good. I had them on the outside. I moved one of them to the inside. When you say one, you mean some. So some gumbo is good. A. Some gumbo is good. Once again, some gumbo is good. It only takes one to be good. And we're okay. Gotta fix my eraser and make it smaller. Well, some gumbo is good. So we know there's one on the inside. At least one on the inside, right? Because it's some. But if I move it to the outside, no gumbo is good. D. So there you go. You can always replay the video because I do want to keep this thing moving. I like to kind of keep my videos under 20 minutes a piece, so we might actually stop it. Write the contrapositive, conditional, and converse and inverse of the following if-then statement. We have an if-then statement. If I don't eat gumbo, then I will have a po' boy. So, now I don't normally do this in class, but I'm going to just assign this P, and I'm going to assign this Q. Again, I'm telling you, I don't normally do this, but to clarify these definitions, I'm going to leave it like that, okay? Because this is a negation, and we typically put a negation in front of a letter, right? I'm not going to do this right now. So again, don't be emailing me or telling me, well, you did this in class, or you said don't do this in class. But in the context of this problem, to clarify these definitions, I think it'll be easier if we do it this way. Got it. All right. Contrapositive. The contrapositive of the if-then statement, P implies Q. That is the statement not Q implies not P. So what that means is I'm going to switch them around and I'm going to do the opposite. So if I don't have a po' boy, should have made something smaller, huh? Then I eat gumbo. The contrapositive switches them around and takes the opposite on negation. So I switch them around. The opposite of I will have a po' boy is I don't have a po' boy. The opposite of I don't eat gumbo is I eat gumbo. The converse just switches them around. Q implies P. So I'm going to switch them around without changing them. If I have a po' boy, then I don't eat gumbo. Notice converse, I switched them around, but I didn't change anything. The inverse, you leave them in place, but you negate them. So I'm going to leave them in place, but I'm going to take the opposite. So if the opposite I don't eat gumbo is I eat gumbo, then I'm going to negate I will have a po' boy, I won't have a po' boy. Okay? This looks like a typo. I don't know why. I just caught that. This really should be the negation. This really should be the negation, okay? So, hopefully I can fix that. The negation, meaning P and not Q. P and not Q. P and not Q is, I don't eat gumbo. And, it's an and. Now you negate the second one. I negate I have a po' boy. I won't have a po' boy. I gotta get used to this pen. Okay, anyway, there you go. So I'm going to fix this one right here, hopefully. Number 4, same type of problem. I'm just getting a little extra practice with this because, again, it shows up on the final exam. So if I have shrimp, then I'll have fish. So P implies Q. P implies Q. So converse is not Q implies not P, right? That's the converse. Nope, sorry. Glad I caught that. Converse is Q implies P. Inverse is not P implies not Q. Contrapositive is not Q implies not P. And the negation is P and not Q. Okay? Just have to memorize them somehow. And make sure you don't do what I just did here. And I get the contrapositive sometimes when I'm not thinking. And I switch and mess them two up. Contrapositive and converse. But the inverse is not P. I'm going to just rewrite this one. Not Q. Alright. So the converse, you switch them around. If I have fish, then I have shrimp. If I have fish, then I have shrimp. Okay? There it is, right here, right at the top. If I have fish, then I will have shrimp. So A. Inverse, you keep them in place, but you negate them. So if I don't have shrimp, if I do not have shrimp, then I will not have fish. If I do not have shrimp, then I will not have fish. So C. Contrapositive, you're going to switch them around, but you're going to negate them. So the opposite of having fish is not. Opposite of having shrimp is not shrimp. Switch them around. If I don't have fish, should be down here, then I will have shrimp. If I don't have fish, then I'll not have shrimp. There it is right here. See how this is tricky? It is not this one, right? It's this one. If I do not have fish, then I will not have shrimp. D. The negation is an and statement. I will have shrimp and I will not have fish. I will have shrimp and I will not have fish. I will have shrimp and I will not have fish. There it is right here. G. Alright, now we're going to move on to the truth tables. For the truth tables, you have to remember, and is true when they both are true, or is true when at least one of them's true. If and only if it's true when they're both the same truth value. And then the only one that's kind of backwards, the if-then is false only when a true implies a false. When a true implies a false, the if-then is false. Otherwise, it's true. So, how do you construct a truth table? Excuse me. Okay, you construct a truth table basically working left to right, realizing you can't construct something until you know the associated values, right? So we want to construct this statement here. You will be always provided the scenarios. These are the 4 scenarios, right? So the first thing I need is not P. The opposite of P, false, false, true, true. Now I can construct the and statement. Not P and Q. I'm going to be working with this column and this column. It's an and, so I need both of them to be true. I don't have both true. I don't have both true. I do have them both true. I don't have them both true. So false, false, true, false. That is the truth table. Yeah, okay? For that statement. Next one. Construct a truth table for the following. So, you cannot distribute a negation. So that's one thing you can't do. You're going to have to work inside your parentheses first. To do this, I need the negation of P. I'm going to need the negation of Q. So the opposite of P is false, false, true, true. The opposite of Q is false, true, false, true. Now I'm ready to construct this statement. To negate not P and not Q. Once again, I'll be working with these 2 columns. It's an and, so I need them both to be true. No, I don't have them both true. No, no, yes. This is the only row where both these statements are true. Now we're ready to take the entire negation of that statement and get our final column. I am simply negating this column. So true, 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 false. Next one. Construct a truth table for this statement. Okay? Now, working left to right, there should really be brackets here. Okay, this is really the order of operations right there, just to let you know. Okay, I can't construct the if-then because I need the inside of the set of parentheses here. So I need not P. So I need a negation of P. False, false, true, true. This is now not P or Q. So I'm constructing this. I'm working with this column and this column. It's an OR. I need at least one T. Got it? No. Got it? Got it. Now that I have this, I can work with the if-then statement. The if-then statement's working with this column and this column. The direction is okay because, remember, the if-then has a direction to it. So it's in the proper direction. In other words, things are not written backwards here. If-then is true when what? Well, it's false when a T gives an F. So this is going to be this column right here. Okay? So a T gives a T, I'm good. A T gives an F, no good. An F gives a T, you're good. An F gives a T, you're good. Now I'm ready for the if and only if. So this is our final statement column. I'm not going to put it right here, but here's the final statement column. I'm going to be working with this column and the Q column. Is an if and only if. That's the operator, right? If and only if. If and only if is true when they're both the same. They're the same. They're the same. They're the same. They're not the same. And there's the truth table for that one. Moving on. Determine if this statement is a tautology. Determine if a statement is a tautology or not. A statement's a tautology if it's always true. A statement is a tautology if it's always true. Now, I will be starting you off with the truth values, okay? I really need to update this test, huh? I need to construct this statement here, okay? I actually provided you the various columns. There was a reason for that, but don't worry about it. I need a negation of P. False, false, true, true. I need Q or not P, so I'm going to be working with these two columns here. Okay, it's an OR. I need at least one T. I got at least one T in every row except the second one. Remember, working with Q or not P. Now I'm going to AND this column with the P column, right? And it's true when they're both true. So, they're both are true. Nope. Nope. And no. So is it a tautology? No, it's not, because this column here would have to be all T's. Well, there's only one of them with T, so it seriously is not a tautology. For the next one, we want to translate the following argument into symbolic form, then determine if the argument is valid or invalid. So my first step is to write this in symbolic form. Our first premise right here is going to be P implies Q. The second premise is going to simply be Q. The band will march. Our conclusion is today is Mardi Gras, which is simply P. So there's our argument, okay, in one form of the symbolic form. Now, what we need to do now is we need to build each one of these premises and the conclusion. So I need P implies Q. I have P implies Q. T gives a T, you're good. T gives an F, you're no good. F gives a T, you're good. F gives an F, you're good. Now, this is a very simple one because I have one of my premises right here. I have a second premise right here. And here's my conclusion right here. That's all I need to determine if an argument is valid or not. Because when the premises are true, which is right here, let me get the marker. When the premises are all true, then that's the only place they're all true. The conclusion needs to be true. That's the only place where we have the premises all true. It satisfies the condition that the conclusion needs to be true, so it is valid. Okay? Anyway, that's it for the video on this one here. I'll probably try to get another one out to you. But anyway, I wish you the best with this.